You can open the trace file using Chrome browser. Here I am using Microsoft Edge. In order to navigate in the systrace, you can use AES WD keys in your keyboard. WS for zooming zoom out and AD for left and right. The systrace I am using is from Android systrace tutorial page. And our sample application is touch latency. For a consistent periodic workload, such as when user touches on the screen and view is updated, the UI pipeline contains 5 to 6 points. So let's start with point number 1. Event thread in Surface Flinger wakes app's UI thread, signaling that it's time to render a new frame. This you can see happening here at 15409.744 millisecond. Event 3 is running on CPU 0. At 15410 ms, UI thread of our sample app is woken up by thread ID 6843, which is thread ID of event thread running on CPU 0. Now come to second point. The app renders a frame using UI thread, render thread and hardware UI tasks using CPU and GPU resources. So here there are a lot of components doing a lot of works, but we will only focus on display pipeline. Our app's render thread has finished rendering the frame here. Now this brings to point number 3. The app sends the render frame to Surface Flinger using a binder, and Surface Flinger goes to sleep. Okay. As you can see here, after the frame is finished rendering at 15423.650 millisecond, our app's main thread sends the rendered frame to Surface Flinger buffer through a binder transaction. At 15433.650, binder thread 6832_1 is woken up by our app's render thread. Here it enqueues our render frame in a buffer. You can clearly see the buffer count increasing at 15424.78, and the Surface Flinger again goes to sleep at 15426.131 ms. Now point number 4. Another event thread in Surface Flinger wakes Surface Flinger main thread to trigger composition of the frame and display the output. This we can see happening at event thread is running on CPU 0, wakes up Surface Flinger's main thread at 15430.530. The thread goes to runnable state from sleeping state. Now point number 5. Surface Flinger handles composition using Hardware Composer, Hardware Composer 2 or graphic libraries. This usually takes 4 to 5 milliseconds. For this, the Surface Flinger latches on buffer, that means acquires the buffer, takes one frame for composition. You can see the buffer count decreasing at 15431.2589 millisecond. After acquiring the buffer, Surface Flinger sets up composition and submits the final frame to the display. Here you can see the method set up Hardware Composer and do composition. Now point number 6. In our trace example, you can see a timestamp 15434.196 millisecond. MDSS FB0 is woken up by thread ID 6832, which belongs to Surface Flinger main thread. Here MDSS FB0 is the display kernel thread for outputting a render frame to the display. So in this way you can navigate through a cycle of a frame. Thanks for watching.